This video deals with the concept of an axis of symmetry, or also known as a line of symmetry. You've come across this in your junior secondary school or even in primary school. Lines of symmetry. They divide a shape into two equal parts. Here we have rectangles, or you could call them squares, but if you actually measure these lines, you know they're the same and they're actually rectangles. So let's call them rectangles or squares. These shapes, here's a line of symmetry of a square. It divides it into two equal parts. They have the same area and the same shape, these two equal parts. Here's another line of symmetry, divides the shape into two equal parts. Here's another one, a diagonal line of symmetry, divides the shape into two equal parts. Same thing here for the triangle. Here's a line of symmetry, and this here is an isosceles triangle actually. This line of symmetry divides into two equal parts. Same thing here, same thing here, same thing here. So here's a line of symmetry, here's another one for the triangle. I've shown three lines of symmetry for this square or rectangle because this is just a sketch, but in reality it's a rectangle. But that's not our concern now. Our concern is for parabolas, the curves you get when you plot quadratic equations, when you plot quadratic functions. The curves you get are parabolas and they have lines of symmetry. Each one has just one line of symmetry, and that line of symmetry always passes through the turning point. I've shown the dotted line here, which is the line of symmetry or the axis of symmetry for this quadratic curve. As you can see, the turning point here is the lowest point in the graph, and in this case it's the minimum, and this line of symmetry passes through it. Here again we have another quadratic curve. We have a line of symmetry shown as a dotted line, and it also passes through the turning point. It's a line of symmetry because it divides this quadratic curve into two equal halves. This line of symmetry is a line. Remember, linear equations, when you plot them you get straight lines. Here we have a line of symmetry. It's a line and it has an equation, so we need a way to determine the equations of these turning points, and that's what we're going to do next. Now to how to determine the equation of the axis of symmetry of a quadratic curve. The graph of the quadratic equation y equals ax squared plus bx plus c. So this is a quadratic equation. Its graph has a line of symmetry given by the equation x equals x star or x asterisk, where x asterisk is minus b over 2a. So what am I saying? The line of symmetry of a quadratic equation, of the graph of it, is given by this formula. The same formula for determining the turning point is given by x equals minus b over 2a. And that's all. So we're going to try some examples. Determine the axis of symmetry. So they're saying determine the equation of the axis of symmetry of the given quadratic equation. The axis of symmetry is simply given by minus b over 2a. For this quadratic equation, b is what? 9. And a is 3. Why? Because it's an equation of the form ax squared plus bx plus c. Coefficient of x is b. In this case, it's 9. Coefficient of x squared a is 3. Equation is x equals minus b over 2a. X equals minus 9 over 2 times a, 2 times 3, which is the same thing as x equals minus 9 over 6, which can be simplified to give x equals minus 3 over 2. This is the equation of the line of symmetry. And what does that mean? Well, let's have a look here. This is the quadratic curve. So this is the curve y equals 3x squared plus 9x minus 17. This curve. And this is the plot of the equation x equals minus 3 over 2. The blue line, the blue dotted line, is x equals minus 3 over 2, and it's a line of symmetry. As you can see, it divides this curve into two equal parts. Now, why is the equation x equals minus 3 over 2 this vertical line? Well, let's try and get a table of values. Now remember, table of values looks something like this for an equation. You have a y value and an x value, and each column represents a point on the graph. This equation is x is equal to minus 3 over 2, and it simply means that regardless of what value y takes, x is always minus 3 over 2. That's what this equation says. X is always minus 3 over 2. So even if y is 0, 1, 2, 8, whatever, x will always be minus 3 over 2. do that red. That's all it means. So when you plot such an equation, x is always minus, so in this case minus 3 over 2 is here, because this could be like minus 1. Here we have something like minus 2. Minus 3 over 2 is here. Minus 3 over 2 is the same thing as minus 1.5. You can check that with a calculator. So minus 3 over 2 is somewhere here. So for every y value, the x value is minus 3 over 2. For every y value, the x value is minus 3 over 2. So all the points lie on this line. And that's why the line is something like this. So for a graph like x equals 1, 1 lies here on the x-axis. Such a graph will look like the following. X is 1 everywhere. So regardless of the y value, x will be 1. Regardless of the y value, x will be 1. So let me use an x here. A cross. Regardless of the y value, when you're plotting a graph, x will always be 1 and you get a straight line. But you don't need to worry too much about that. The key thing here is the following. The axis of symmetry is given by this equation. And B and A are determined by just inspecting the quadratic equation, comparing it to the general form, and deducing what B and A are. And subbing B and A here, simplifying, and you get your equation. And that's all, you stop. So here's another example. Determine the axis of symmetry, the equation of the axis of symmetry of this quadratic equation. Now the hard part is just in determining what B and A are. So we have y equals minus x squared minus 10x minus 2. We need to be in the form ax squared plus bx plus c. So I'm just going to rewrite it as y equals minus x squared. So an ax squared term minus x squared plus, I'm going to put a plus, bx, well, minus 10x. Remember, plus minus 10x same thing as minus 10x, because plus times minus is minus. So let me just do this. Plus minus 5 is the same thing as minus 5. Plus minus 6 is the same thing as minus 6. Minus 4 can be written as plus minus 4, because plus times minus is minus, and you have your 4. So minus 10x is the same thing as plus minus 10x. Minus 2 is the same thing as plus minus 2. So now we have these equations in the same form. You have an ax squared term, so a constant times x squared. Here we have minus 1, so I'll put a minus 1 times x squared. I'm going to drop them out now, but always know it's there. We have a plus. We have a bx term, so a constant b times x. We have minus 10 times x plus we have our c. So now we can compare the two equations and determine that a, the coefficient of x squared, is minus 1. B, the coefficient of x is minus 10. And we're pretty much done, because the equation of the axis of symmetry for this graph is given by minus b over 2a. In our case, that's minus, what's b? B is minus 10. So we have to be careful here. Over 2 times a is minus 1. It simplifies to give 10 over 2 times minus 1 is minus 2. So we get x is equal to, well, 10 over minus 2 is same thing as minus 10 over 2. So this is x equals minus 2 here, 1, 2 and 10, 5. X equals minus 5. As you can see here, this is the plot of the quadratic equation here. And this is the axis of symmetry, x equals minus 5. You can see the plot here. All points on this line have an x coordinate of minus 5. That's what the equation is saying. X equals minus 5 says all points on the line have an x coordinate of minus 5. And as you can see, it divides it into 2 equal halves. So this is all you need to know. The formula for the axis of symmetry of a quadratic equation, and you need to be able to just deduce what a and b are by comparing the two equations. In this case, because of the minus signs, I had to change minus 10x to plus minus 10x, which changes nothing. It just gives us a quadratic equation that is in the exact form, the exact general form, so you can easily pick b as the coefficient of x minus 10. The key thing here was just to have a plus and a plus, a plus and a plus. So you could just pick the coefficient of x as b and the coefficient of x squared as a. In this case, minus 1, because x minus x squared is the same thing as minus 1 times x squared. So the coefficient of x squared is minus 1.